Hello everyone, we are Team Synergy from the Department of Computer Science and Engineering at the University of Moratuva. Our final year project is titled Resource Allocator and Mapper for Efficient Transactions. Classified ads are a simple idea, connecting people who have things with those who need them, but doing this efficiently, especially in a multilingual setting like Sri Lanka, presents real challenges. We were motivated by the lack of a unified platform with smart matching, a seamless experience, and crucial multilingual support. The current landscape in Sri Lanka suffers from fragmented platforms, poor ad categorization, no semantic matching, and little support for Sinhala. These issues reduce efficiency and user satisfaction. Our research had three main objectives. Develop classification models to organize ads into a standard taxonomy. Build a model to match wanted and offering ads in English and Sinhala. Evaluate different multilingual embedding models for both classification and matching. We analyzed platforms like Craigslist, Oodle, and Facebook Marketplace. Craigslist and Oodle lack automated matching. Facebook uses AI, but supports only offering ads, not wanted ones. So we defined three requirements for our system. Automated aggregation from multiple platforms, intelligent categorization and detail extraction, a smart matching engine that connects requests to resources. Our system has three main modules. The Scraper bot collects ads from various classified ad sites. The Content classifier organizes the ads in the main and subcategories. The matching engine finds the best matches between offering and wanted ads. To handle multilingual content, add inconsistencies, and low resource categories, we used XLMR and LABSE embeddings and applied data augmentation techniques. To ensure consistency in classification and matching, we designed a clear taxonomy with three main categories: vehicles, electronics, and property. Each of these was further divided into specific subcategories to allow structured browsing and accurate analysis. We collected over 115,000 ads from major Sri Lankan platforms. Pre-processing involved standard text cleaning, like removing HTML tags, punctuation, and emojis, and then generating sentence embeddings for each ad using multilingual transformer models. We used two powerful multilingual models: XLM Roberta Base, which provides token-level embeddings, LABSE, which gives language-agnostic sentence embeddings optimized for cross-lingual similarity. These models helped us handle ads written in both English and Sinhala, ensuring consistent understanding across languages. To improve representation quality, we experimented with several feature engineering techniques, such as concatenating embeddings of title and description, using weighted averages to emphasize more important fields, and directly embedding the combined text fields for a holistic representation. To make sense of the large volume of scraped ads, we needed a way to organize them consistently. This brought us to our classification system, which plays a central role in structuring the data. We implemented a hierarchical classification pipeline. The first stage identifies the main category of the ad and whether it's a wanted or offering type. The second stage assigns a more specific subcategory using dedicated classifiers tailored to each main category. We experimented with a variety of models, including SVMs, logistic regression, XGBoost, SGD classifiers, and neural networks, all trained using multilingual embeddings generated from XLMR and LABESE. We evaluated the classification models using metrics like accuracy, precision, recall, and F1 score, and observed very strong and consistent performance across all tasks. Models trained with LABSE embeddings performed particularly well on multilingual data, and neural networks showed strength in capturing the nuances of subcategories. While the system proved highly reliable, we did encounter challenges, most notably imbalanced data sets, especially in the case of wanted ads, which were underrepresented. To mitigate this, we generated synthetic samples and applied careful model tuning to maintain both high performance and interpretability. After classifying ads into structured categories, our next goal was to build a system that could intelligently match wanted ads with suitable offering ads. One of the major challenges we faced was the limited availability of wanted ads, which made it difficult to train effective matching models. To address this, we adopted a hybrid dataset strategy. Alongside real data, we generated synthetic wanted ads using Gemini 2.0 Flash, based on existing offering ads. This gave us a more balanced and diverse dataset, including a manually created gold standard set of high-quality matched pairs. For the matching task, we used a Siamese neural network, which is well-suited for similarity-based problems. The architecture consists of two identical branches, one for the wanted ad and one for the offering ad. Each branch processes both textual, title and description, and categorical, main and subcategory, features, and outputs a fixed-length embedding vector. The similarity between ads is then measured using cosine similarity, allowing the model to identify the most relevant matches in the embedding space. We chose this architecture over the traditional two-tower models because our task is symmetrical. Either ad can serve as the query, and shared weights help regularize the model, especially in a low-resource setting. We train the network using a combined loss function, a weighted average of cross-entropy and contrastive loss, along with in-batch negative sampling to improve training efficiency. To evaluate the system, we used recall at k as our primary metric. This reflects how likely the correct match appears among the top k results, which directly impacts the user experience in real-world searches. We compared several configurations, with and without the Siamese architecture, using LabSE and XLM-R embeddings, with and without categorical features. Across all settings, the Siamese model with LabSE embeddings performed best. The most effective setup used combined text embeddings and included category metadata, which added valuable context and improved overall recall. These findings demonstrate that supervised similarity learning with language-agnostic sentence embeddings is highly effective for our matching task. However, we still face limitations, such as difficulty handling Singlish terms and inconsistencies in place names across languages. As future work, we propose to fine-tune embeddings on domain-specific Sri Lankan content and explore a hybrid system that combines both semantic similarity and traditional keyword search for improved coverage. This is the Synergy platform. Users can directly explore three main categories: property, vehicles, and electronics. In the property section, listings are aggregated from multiple sources. Filters like land or house instantly update the results. Our system handles both English and Sinhala ads seamlessly, showcasing accurate categorization. The same smooth experience applies to vehicles and electronics. Users can quickly find cars, electronic accessories, and more, all organized through our intelligent classification system. To find an apartment, the user posts a wanted ad in Sinhala. Our system classifies it instantly and, with one click, returns matching offerings, connecting the request to real available listings. Here's another example. The user posts a wanted ad for a 2012 Kia Sportage. Instantly, the system recommends matching SUVs from that model and nearby years. The user posts a wanted ad for commercial space facing Duplication Road in Colombo. Within seconds, the system recommends listings that match the rental need. Finally, the user posts a wanted ad for a used iPhone 13 Pro Max. With one click, the system returns matching listings available for sale. That's Synergy. Thank you.